Hello everyone. Welcome to this session on Reactor Protection System (RPS). In this presentation, we will discuss about the fundamentals of nuclear safety, the role of deterministic and probabilistic safety approaches, and the RPS function, the prevention of uh, prevent the accident and mitigate the risk of nuclear power plants. We will start understanding how the nuclear safety is structured and the type of accidents that are considered in the design of the nuclear power plants. If we look into the safety demonstration, it is mainly about it has two major parts. In the design of a nuclear power plant, it has two major parts. It is first one is deterministic approach and the second one is probabilistic safety approach. First one, the deterministic approach. In this method, we can define a list of anticipated events based on their probability of occurrence and the consequences of radiological leak. We can classify them. So these are the categories that comes under design basis accident or design basis category, like we can say DBA or DBC. So what are the events coming under these categories? We can look on to that, like a single failure component, operator error or SPO. These events comes under DBA. And any of these DBA events occurs, it will not further escalate to a severe accident condition or a radiological leakage, because it's already considered at the design stage, and the further redundancy and reliable steps were taken care of at the design stage itself. And this approach forms the foundation for the RPS, which ensures that if the failures occurs, the reactor shut down automatically. Second, probabilistic safety approach (PSA), which examines rare and unforeseen situations that may lead into severe accidents, and it may comes under the DEC condition, that is design extension condition. Examples of DECs are multiple simultaneous failures, the external hazards such as earthquake, floods, and the core melting scenarios like severe core damage scenarios like fuel melting. So by adding additional safety features, we can overcome or reduce the likelihood of the core melting. Thus, combining the probabilistic and deterministic approach, we can ensure the framework for the nuclear power plants. Now we will look into Reactor Protection System (RPS). The RPS is a critical safety system in a nuclear power plant. The main function of an RPS is continuous monitoring of the physical parameters, and if any abnormal condition occurs, the reactor trip will be initiated, and if further needed any additional support, then the emergency system will be activated. So now we are looking into a functional diagram of a protection system. So now we can see that there is the RCB, and inside that we are having one RPV, and top of the RPV, the yellow color, which is showing the CRDM, and we are feeding electrical power continuously to the CRDM through reactor trip breakers. And to the reactor trip breakers, we are giving signal from the RPS. So the RPS and the control systems for the normal operation control systems will be having the physical parameters continuously monitoring, and if any abnormalities occur, the RPS will act and it will give the trip signal to the trip breakers. So the CRDM power will be cut off. This causes the control rods to drop into the reactor core by gravity, which is cramp, thereby shutting down the reactor. And if necessary, the RPS also triggers the safety injection system to inject the coolant into the reactor in case of there is a loss of coolant accident, LOCA. And to reduce the containment pressure and the temperature in the extreme scenarios, the containment spray actuating system will be activated. The RPS is designed with redundancy and diversity, ensuring that if one system fails, another will take over to guarantee the reactor shutdown. The RPS continuously monitor in-core, ex-core and process instrumentation systems to identify if there is any unsafe condition and initiate shutdown when necessary. Thank you for your attention.